Hello everyone and welcome to this event. Having signed up for this event, you will be aware that this presentation is about the result of tests conducted with John Deere tractors, powerful John Deere tractors, as they are the 8R, 8RT and 8RX ranges. During testing, these tractors were fitted with tracks from Camso, a company which is part of the Michelin group, as well as Michelin tires. We used different configurations, as obviously we had 2-track versions, 4-track versions, and we also tested single and twin tire fitments. And finally, we looked at the effect of width in relation to tires and also ballast. So our goal today is to finally present these results to you, farmers, agricultural entrepreneurs, to really share this knowledge with you, which we hope will optimize the performance of your tractors on your farms, but also to look forward when you are considering an investment in the future, to have all the information you need to be able to make the right choice based on your uses and expectations. So, first things first. I suggest we start with a little introduction for this event. Let's do a little introduction, as we're very lucky to have multiple skill sets represented here today, with John Deere, which is obviously representing the tractors. We also have tire and track experts from Michelin, who will be here to answer your questions. And we also have the opportunity to have 2 farmers from Charente and Marne, who have their tractors fitted with the configurations I just mentioned, plus different tractors, as there's the 8R, the 8RX and the 8RT. So the idea is to bring together John Deere's expertise in tractors, our equipment expertise, but also feedback from these farmers, allowing us to effectively compare the experience and tests. So then we will look at configurations, something which is essential, as we know that tire equipment, track equipment, but also ballast are important factors which affect performance. So it will be important to be clear to put the results into perspective. And then we will get back to the heart of the matter with performance tests. We will also briefly explain how these tests were carried out, and this is very important. So there will be a Q&A session, and we've dedicated a reasonable amount of time, which should be around 45 minutes to an hour. We're not against the clock, so we will take the time to answer all your questions, and so for that purpose, I invite you to ask your questions throughout the presentation. In the top right, there's a small bubble with a question mark. You just need to click on it, ask your questions, and they'll be shown on the screen so we can answer them. Please be as precise as possible with your questions, referring to the performance information for which you would like further explanation. The more precise your questions, the more confident we can be that we've understood the question and be able to answer it. So, let's start with the introductions, and let's begin with John Deere. From John Deere, we're delighted to welcome Julien Saint-Laurent, who's the France head of marketing for John Deere, and we also have Sébastien Jacquier, who's head of sales. From Michelin, we have Guillaume Vidal, the France marketing manager for agriculture and construction. We also have Christophe Chezot, who's our France technical expert for agriculture and construction. And we also have, virtually, as he's not in France and it's difficult for him to travel at the moment, Chris Thibault, who is our agriculture systems and tracks product expert. We also have Jacques Delphon, virtually if needed, who's our tracks expert on the other side of the Atlantic. I'm Bastien Nourrisson, and as you might have guessed, I will act as your host today, and I'm responsible for experience and communication at Michelin, specifically for agriculture. Now I will let our farmers introduce themselves. We're delighted to welcome them today and for making the effort to travel here today, as we have Laurent Gauthier, who's a farmer and agricultural entrepreneur from Charente. Laurent, could you introduce yourself and provide some information about your activity, your farm, please? Hello everyone, I'm a farmer and wine grower in South Charente, about 30 kilometers from Cognac. We currently farm 400 hectares of cereals and 43 hectares of vines. It's a family farm, and we sow, thresh, everything related to cereals and wine growing. We sow around 1,500 hectares and thresh around 2,000 hectares. And Laurent, without going into too much detail about your configuration, as we'll get back to it later, what type of tractors did you have from these powerful tractors? The 8370 fitted with tires, and then we moved to an 8RX 370. So you will understand that it's significant that Laurent has joined us. He will really be able to offer that experience in different tractors, and in this case 4 tracks and 4 tires and even 8 tires, which I think we'll discuss later. And the second farmer with us is Damien Monuel, also a farmer and agricultural entrepreneur from Marne. Damien, the same question. What can you tell us about your activity, your farm? So the family farm is in the southeast of Marne, around 800 hectares. Some is chalky champagne, quite light soil, and some is damp champagne with more clayey soil. Currently, we've stopped the farming business. We're just farming to meet the farm's needs, to be more precise and efficient. In terms of farming equipment, at the time we had a first-generation 8320 rear-front twin fitment with 650/85 E38, and then we moved on to an 8360 RT with 760 tracks. We replaced the 8360 RT this year with an 8370 RX, and alongside this we have 2 lead tractors for farming, i.e. alongside this 8370 RX we have an 8370R fitted with Michelin 900/65 R46 tires. Thank you very much, Damien. We have a clear idea of the tires and tracks. That's great. So, before starting with performance, just to give you a little bit of context on why we conducted these tests, I will ask Guillaume Vidal to explain why it's worthwhile for Michelin to have performed these tests. Guillaume, I'll hand the microphone over to you. Hello everyone. As you said in the introduction, Bastien, the goal shared by Camso, John Deere and Michelin is to help you, our customers, to make the right choices when purchasing equipment for your vehicles, whether tires or tracks, in order to get the most out of our offers, depending on your needs and expectations. As you know, Michelin is now a supplier of track solutions with the acquisition of Camso in 2018. Thanks to our excellent relationship with John Deere, particularly in relation to the development of new mobility solutions for their vehicles, they supplied us with an 8RX, a tractor equipped with 4 Camso tracks, an 8RT, a tractor equipped with 2 Camso tracks, and an 8R, a tractor for which we varied the tyre configuration during testing. We will explain the configurations we tested a little later in the presentation. We were able to organize a comprehensive and ambitious test program, bringing together experts on tyres, tracks and vehicles, as well as expert agronomists to test all the key aspects of the tractor configuration's performance. These tests took place at our primary research site in France, here near to Clermont-Ferrand, and with nearby farmers. The objective was to offer evidence-based results to allow everyone to make the right choice with regards to their needs and uses. Thank you, Guillaume, for the context, and the same question for John Deere. Why are these tests worthwhile for the John Deere Group? The 8RX is a tractor which has recently arrived in Europe. As I'm sure you know, it was developed in the United States, in Waterloo, in the middle of the Corn Belt, so lots of tests were carried out in those sorts of conditions. The North American conditions are a little different. The 8R always has a twin fitment. It's a tractor which does a lot of corn sowing, so operations which are relatively different to the situations we might encounter here. But the idea of this partnership is to be able to test performances in a European environment for European situations and to compare the tractors. Excellent. Many thanks, Julien, for these explanations. I'll now show a video with some images from these test campaigns. So as you can see, we had an intensive test campaign as it took 1 month, with multiple configurations and a huge undertaking by our test teams. I suggest that we move on to the configuration section, with a small point on the tractors. We've already mentioned that there are 3 8 ranges, 8R, 8RT and 8RX. I'll pass over to John Deere to explain a little about these tractors. Sébastien. Hello everyone. So we reached the decision with the Michelin teams to use configurations, models which are as similar as possible. So we chose the most powerful model in the 8 series range, which is the 410 model, which has been adapted to an RT and RX version. And as I'm sure you know, this model is fitted as standard with an E23 transmission, in John Deere lingo, which is the robotized power shift transmission used in these 3 tractors. So 3 equipment options, 6 tested configurations, i.e. the tracks were each tested as they were configured. We'll see the details of that. And for the tyre version, as Damien said, we established 4 versions, so with different tyre equipment, which Guillaume will explain in a moment. Indeed, Guillaume, you're going to explain that, and it's very important to have the configurations in mind. Very often we ultimately see different user results with identical tractors in terms of performance, so we need to verify the balance between the tractor, the tool, and the equipment. When I say equipment, I mean tracks and tires. There's also the notion of ballast, which is very important. So to put the results we're going to present in perspective, it's important to have all the details presented by Guillaume in mind to interpret these results. So Guillaume, I'll let you present the configurations. Yes, it's very important for each configuration to be really clear for everybody. We will repeat this information throughout the presentation of results, as we sometimes need to qualify these results. The equipment changes, the loads too, and this has an effect on the different measured performances. Let's start with the tractor fitted with tyres, the 8R. In all the tested configurations, we fitted it with the Michelin Axiobib 2 range, a range dedicated to powerful tractors, with Michelin Ultraflex technology, which means that the tyre has excellent deflection capacity, which increases the surface in contact with the soil. It's a range which we can classify as low pressure, as when combined with the VF very high flexion standard, it allows us to carry an extra 40% load, or lower the pressure by 40% compared to a tyre with the same dimensions, but classic technology for a given load. This is very important because if we had performed these tests with classic radial technology tyres, the tractors fitted with tyres would have had performance levels below what we were able to measure. The front axle is the same for the 4 configurations tested on the tractor fitted with tyres. It's the VF650/60 R34 Michelin Axiobib 2. For the rear axle, we tested 2 tyre variants. The first, the VF710/75 R42 Michelin Axiobib 2, which is a standard cross-section tyre for this level of power, and which offers a cross-section width of 710 millimeters. The second is the VF900/60 R42 Michelin Axiobib 2, which is a 900 mm wide tyre for greater load-bearing capacity. All tyres are identical in diameter at 2.15 meters, which is the maximum approved diameter for this range of tractors. All the tyre version tests were performed with these dimensions, and we varied other criteria to get different configurations such as ballast and twin fitments. So in detail, on the first tractor in the top left, you have the first configuration, which is a 4-tyre tractor with Michelin Axiobib 2 VF 710/75 R42 single fitment and light ballast of 15,500 kilos, which we will call the 8RV 710 light ballast for the rest of the presentation. Next, the tractor to your right in the first table as well, the 6-tyre tractor, twin fitment on the rear only, the same dimensions and the same light ballast. The only weight difference between these 2 configurations comes from the twin fitment. In this case, it's 16 tons and 950 kilos. We will call it 8R VF 710 twin fitment light ballast for the rest of the presentation. Finally, in the bottom left, the third configuration, the 4-tire tractor single fitment with Michelin Axiobib 2, the same dimensions as the first configuration, which is just above, but the heavy ballast version. In this case, it's 18 tons and 225 kilos. And we will call it 8R VF 710 heavy ballast for the rest of the presentation. And finally, the last tyre configuration, which was tested in the bottom right, the 4-tire tractor wide single fitment with Michelin Axiobib 2 VF 900/60 R42 with heavy ballast, which is 18 tons, 240 kilos. We will call it 8R VF 900 heavy ballast for the rest of the presentation. Now let's move on to the tractors with tracks. So, for the tractors with tracks, we'll start with the 8RT, which is fitted with two Camso AG 6500 tracks. The width of the tracks is 30 inches or around 76 centimeters. This 2-track tractor is not ballasted, as we wanted to keep it similar to the tyre versions with ballast to have points to compare. And finally, the last tractor tested is the 8RX, fitted with Camso RD 4500 tracks, 24 inches wide at the front, which is around 61 centimeters, and Camso 30-inch tracks at the rear, which is around 76 centimeters wide. This tractor was also not ballasted, and it weighs 20.3 tons. So we must remember that to understand these results, the 8R heavy ballast and the 8R twin fitment are very similar and so comparable in weights to the 8RT. The 8RX Camso 4-track configuration is the heaviest, and the 8R configuration with the Michelin Axiobib 2 VF 710/75 R42 tyres and light ballast is the lightest tractor in weight. This lower weight has an impact on certain performances. We could have worked with identical weights, but we wanted to stick to the commonly used configurations to explain the impact of weight on different performances. Thank you, Guillaume. Indeed, it's very important to have these configurations and these notions of load, as we know that they will impact performance. So, let's present the test results while presenting the protocols at the same time. For the test, as a reminder, as you will have seen in the video, we will start with the traction performance, one of the most widely expected performances from high-power tractors. Then fuel consumption in the field, agronomy and soil preservation, fuel consumption on the road, comfort and behavior on slopes. So if we start with the traction part, before looking at the results, it would be interesting to have some feedback from our farmers. Laurent, could you tell us about your experience in terms of traction in relation to the 8R equipment and your current 8RX equipment, as you told us? Do you have some feedback to share with us? Yes. So before, we had the 8370R with 900/60 R42 tyres. Initially, it wasn't weighted. We were between 18 and 22% slippage. Then we fitted the wheel weights and we moved to between 10 and 12% slippage with a 5-meter tool. Now we're at 6 meters, and with the RX we have between 2 and 3% slippage maximum. Okay, so you really noticed an improvement by ballasting your tractor, definitely. For the tyre version? Yes, that's right. Did you have the chance to test twin fitments for traction work, or did you keep it more for the sowing, soil preparation part? No, when twinned, we had a 6250 twin fitment for sowing, front-rear twin fitment with 500/80 at the rear, and on slopes we still had slippage. Okay. And this year I sowed using the 8RX and there's no contest. Okay, great. Damien, same question. You had the 8RX, the 8RT and an 8R, which, if I recall, has a more unusual setup as it has 2.3-meter tyres, which is not approved, but do you have feedback to offer us? I know that you have a Terraland, which generates significant traction force. Yes, on the farm I spoke about slightly more clayey soils. So we have two tools which require a lot of traction, which are the top-down 7 meters and the Terraland 4 meters. We need to transfer the power to the soil, and so when using the 8360 RT, the tractor with 2 tracks, Straight away we saw that there was no slippage, or almost no slippage when pulling. We transferred all the power. And for our second tractor, to support that tractor a little, we chose a tractor with 900 tires, saying that we would ballast it as much as possible to have two complementary tractors. But we really improved the traction capacity and reduced slippage by ballasting the 8370 with 900s. But we still had a slippage rate 10 to 15% higher than the tractor with two tracks. So when we replaced the 8360 RT, we chose an RX tractor with 4 tracks, and we noted the same thing. Very low slippage during traction work. Okay, do you remember in terms of the ballasting we just discussed with the different testing configurations, the 8R with ballast, can you remember roughly how much it weighed? We fitted it at over 19 tons with a 4-ton weight on the rear linkage and around 1 ton on the front weight. In comparison, like you in the configuration, for us the RX is not ballasted at all, i.e. there's no weight on the RX, while it's already quite heavy. So they're around the same weight, 19 tons, and the ballast improves it. But a tire always has some slippage, and we can see the difference straight away when getting in the cab. We see the grip difference between the two tractors straight away. Okay, so in summary, despite the ballast effect, for work which requires a lot of traction, your RT and finally your newly acquired 8RX are much more efficient, is that right? That's right. Great, well, thank you for this feedback. Now we'll get on and we'll compare the feedback from Damien Laurent with the results from our tests. And we'll start with a comment on the traction protocol with Christophe in the video. So I suggest we watch a presentation video which will help us to understand our methodology for these traction tests. So we conducted these tests on 3 different types of soil to have a representative range of different conditions that you might encounter at your farms. We had 2 plots of corn stubble here on the screen, one with a clay soil, so heavier, the other with a lighter sandy, silty soil, and the third plot was a stubble ploughed lot, so loose soil. For our tests, we used the so-called Convoy Method. The tractor for which we were collecting measurements is the lead tractor. For the tests, of course, we varied the ballast configurations, the tyres fitted, and of course we changed the tractors, 8R, 8RX, 8RT. You can see in the videos that the lead tractor is linked to the brake tractors with a sling. These brake tractors help keep the convoy at a steady speed. And when we modify their speed, when we vary the speed of the brake tractors, we change the level of effort and slippage to reproduce the use of a tool. We prefer this method as it's more reliable to compare traction performance. It helps avoid variations linked to the soil which is never completely homogeneous and which can skew results. It also helps avoid small differences linked to coupling and tool adjustment from one tractor to the next, which also skews results. So, to make the results more reliable, we repeated the measurements several times for each configuration, and at several different points in the plots. Each time we recorded the traction at the hook, the rate of slippage, and the tractor's fuel consumption. So, as you're going to see on the following graphs, we're capable of measuring the tractor's tractive effort depending on the rate of slippage. Let's move on to the results. On the graph, I will pass over to Christophe. So the first results I will present are the results obtained on clay soil, so the heavier soil. To read the graph, the horizontal axis is the rate of slippage and the vertical axis is the tractive effort in decanewtons, DAN. To help you get your bearings, 1,000 DAN corresponds to a ton. So when we see 10,000 DAN of tractive effort, that corresponds to 10 tons. To harness the power of a tractor with tyres, we accept that the rate of slippage will be between 10 and 15%. For our tests, we chose 12% as a benchmark. Let's look at the first curve in brown, which is the 8R with single tyres. VF 710/75 R42 Axio Bib 2 with light ballast. This configuration has the worst tractive effort, and that makes sense as it's the lightest tractor at 15.5 tons and with the narrowest fitting. You have a reminder of the configurations in the bottom right. Let's look at the second curve now, in red, which corresponds to the 8R with single tyres, VF 710/75 R42 heavy ballast. In this configuration, we've added 2.7 tons of ballast, increasing the weight from 15.5 tons to 18.2 tons. This additional ballast offers 10% extra traction, which demonstrates the effect of ballasting on traction. The next curve, the purple curve, still with heavy ballast, which tested the effect of width with VF 900/60 R42 Axio Bib 2 fitted to the rear. We can see that at the same diameter, increasing the width offers almost no additional traction. We will see later that the 900 tyre offers benefits in terms of soil preservation. Next, we have the pink curve, which corresponds to the light ballast configuration. Rear twin fitment with VF 710/75 R42 Axio Bib 2. Compared to a single mount with 710s, the rear twin fitment helps to improve traction by 14%. Let's move on to tractors with tracks. An average rate of slippage of 5% allows us to fully harness the traction capacity of a tractor with tracks. So at 5% slippage, the 8RT with 2 tracks, shown as the green curve, has 25% additional traction compared to the best tyre configuration, which is the rear twin fitment at almost identical weight. Indeed, it's just an extra 600 kilos for the 8RT. We'll come back to this, but the tracks, not surprisingly, offer tractive capacities that help to improve per hectare productivity with wider tools. To finish off, the 8RX with its 4 tracks improves traction performance even more. At 5% slippage, we have an 11% improvement in traction compared to the 8RT with 2 tracks. In difficult conditions with a 10% rate of slippage, we have an extra 18% traction, so it will be more efficient in more extreme and difficult conditions. What can we draw from these results? For a tractor fitted with tyres, ballast is a crucial element for traction. A twin fitment improves this even further. Adjusting these 2 parameters helps optimize the transfer of power and/or responds to needs regarding wider tools. The option to work with wider tools to improve productivity. Regarding tracks, they create even more opportunities to work in extreme conditions or to fit very wide tools, also to improve productivity. If we continue on the line of tools, as you can see on the left of the graph, on an indicative basis, we've translated the tractive efforts into cultivator width. If we take the example of the tractor fitted with tyres, by adding a front twin fitment to the rear twin fitment, if the conditions were suitable, this would allow us to move from an approximate 8-metre cultivator, 8/10 metres, to a 12-metre cultivator, still with an acceptable rate of slippage. In France, we primarily use twin fitments to protect soil, but our tests show that they also allow us to gain additional traction. Our tests also demonstrate the traction of tractors fitted with tracks. The traction capacity of tractors fitted with tracks starts where the tractors fitted with tyres ends. While a tractor fitted with tyres can offer a tractive effort of 9,000 DAN with an acceptable rate of slippage, the tractors fitted with tracks can get up to 13,000 or even 14,000 DAN, thus allowing us to have 12 or even 14-metre cultivators. Thank you, Christophe. I think we also did these tests on different soils. So yes, 3 different types of soil. You can see the curves which correspond to the measurements taken on sandy, silty soils, so lighter than the previous curves. The curves are similar differences, so I suggest I don't go into more detail as they're similar results. Great. And a third type of soil? And the third type of soil which I mentioned, a stubble ploughed plot. In this configuration, we only tested the 8R with heavy ballast with the 900s and the 2 tractors with tracks. Even if the percentages are a little different, the trends are the same and the order is also the same. Great. Thank you, Christophe. So, would John Deere like to add anything or offer feedback? Are you surprised by these results? Or not really surprised? With the 8RX design, we wanted to have the benefit of the 8RT and the 8R, and we can see that the 8RX does very well, like the 8RT, even a little better thanks to its 4 points of support. So it was expected that the tracks would offer better traction. What is really important today, we have tractors that can reach such high power levels. We realize that in some cases, we need tracks to transfer this power to the soil when we're using them. An 8R and 8000 a few years ago, we were at 300 horsepower maximum. Now we're at 410, which is over 450 HP at maximum power. So mechanically, there's a lot of power to transfer, and tracks are very beneficial in that regard. For me, the crucial point is the ballast. You demonstrated that very well with an 8000 tractor, which is already quite heavy. Ballast is still very important, including for all the people watching who don't necessarily have this level of tractor power. It's highly relevant. We talk and continue to talk about it on a daily basis. We'll continue because there's a lot to gain, much more than with lighter tractors. We can see that. A 7R now, it almost reaches 400 HP. A 350 HP has maximum power of around 380 HP, and it's a tractor which is much lighter. When we want to transfer this power, we really need to focus on ballast, which is why there's an interest in ballast solutions, which are easy to fit and remove from the cab, for example, and ballast on new tractors and tractors already in use is an unlimited opportunity for improvements. Great, thank you very much. So if we summarize what Laurent and Damien told us and the results, would you confirm that these tests generally confirm your experience? Yes, absolutely. Perfect. So before moving on to the next test results on fuel consumption in the field, the same question. We're going to start with you, Laurent and Damien. So if we start with Laurent, do you monitor fuel consumption in the field? And if so, what have you noted in relation to the different equipment you've used? I find that I consume less. On the road, I don't know, but in the field, definitely. With the 8RX, is that? Yes, with the 8RX, because there's less slippage, so automatically you consume less. I prepared the soil. I used the tine stubble cultivator at a depth of around 25 to 28 centimeters. And per hectare, I'm at around 16 to 18 liters per hectare. And for preparing the soil before sowing, we were at around 6 and 8 liters per hectare. And now when sowing, I'm between 3 and 5 liters per hectare. Okay, Damien, same question for you on fuel consumption in the field. Do you track this performance? Do you have feedback to offer? Yes, of course. We always try to keep an eye on consumption per day and per working hectare. In this regard, the tractor is much more efficient at using the tracks. We spoke about that in relation to slippage, which is lower. So automatically, the non-road diesel consumption in liters per day is also lower. I've just one tool I used this year with the 8RX, which is the Rexius 8.3 meters, which has a press roller with tines which work at 10 centimeters, and the roller which is 13 tons. We work at a speed of 14 to 15 kilometers an hour, and we get down to 5 to 6 liters per hectare when preparing with a tractor fitted with tracks, which we can't achieve with our tractor fitted with tires due to slippage. Great, thank you very much. Well, we will establish this correlation. We will look again at this notion of slippage, which has an obvious effect on fuel consumption. So, Guillaume, I'll let you present the results for tests regarding consumption in liters per hour. To start, this feedback is very interesting. We'll be able to compare it with the measurements we took. So, fuel consumption in the field has a direct correlation with traction. The measurements were taken at the same time as the traction tests, and Christophe has explained the protocol for that. Traction is one aspect of performance among others for you, but efficiency in terms of the fuel consumed is also very important when it comes to profitability. The results presented on this graph are fuel consumption in liters per hour on the vertical axis to the left against tractive effort in DAN, which is decanewtons, on the horizontal axis. What we can see is that for tractive efforts of up to 7,000 DAN, that's up to 7 tons, there's very little difference between the various configurations. Above 7,000 DAN, the differences increase gradually up to 8,000 DAN, so 8 tons, and get bigger from 9,000 DAN. It is possible to optimize the tire configurations by adjusting pressure or fitting extra ballast, but we're limited by the capacities of the tractor fitted with tires, which is logical, as we can see in the traction test results which were just presented. We won't look too much into consumption per hour, as it's not necessarily the most relevant figure to consider a tractor's profitability in terms of its configuration. It's therefore worthwhile to express it in terms of the surface area worked in order to measure the productivity of different configurations. So let's move on to per hectare consumption. So on this second graph looking at consumption, on the vertical axis we have per hectare consumption in liters and the tractive effort in decanewtons along the horizontal axis. So the test report is the same as the traction testing. So we program the tractor to travel at 10 kilometers an hour, knowing that if the rate of slippage is around 10%, its actual GPS speed will be around 9 kilometers an hour. Then we vary the tractive effort depending on the configurations. Fuel consumption initially was very similar. The gap widens if we compare this per hectare consumption with, here for example, for traction of 8,000 DAN, so 8 tons, a 30% increase in per hectare consumption for the 8R solution with VF 900/60 R42 Michelin Axio Bib 2 compared to the tractors fitted with Camso tracks. This gap is explained by the higher slippage, as we saw previously. Slippage increases based on tractive effort. And at high levels, like here at 8,000 DAN, we get a high rate of slippage at around 20%. This slippage causes a big increase in consumption, while for this level of effort the tractors are more comfortable with 5% slippage. It may be noted that a solution with a front-rear twin fitment would be more efficient, but the choice was made to focus on this single wide tire arrangement, as this is more common on the French market. Let's examine the idea of per hectare productivity using the following table. So, in this table, we wanted to highlight the improvement in per hectare productivity in a tractor fitted with 4 Camso tracks, such as the 8RX, provided it's fitted with a suitable tool. So we've highlighted the tractive capabilities of the different configurations by using a feasible tool width. So, for the 8R with 4 tires, at a slippage rate of 12%, the tractive effort is 6,500 DAN, which corresponds to an 8-meter cultivator. For the 8RT, so the 2-track solution, we produce a tractive effort of 9,000 DAN, so 9 tons, at 5% slippage, so a 10-meter cultivator. And finally, for the 8RX, equipped with 4 Camso tracks, we have an effort of 11,000 DAN at 5% slippage, so a 12-meter cultivator. And if we look at productivity now, the 8R with an 8-meter cultivator works 7 hectares per hour, while the 8RX with a 12-meter cultivator can work 11.4 hectares per hour. So with like-for-like power, this 4-track configuration allows us to fit a 50% wider tool, and thus increase productivity by 63% between the single tire solution and the 4-track solution. If we now turn to per hectare consumption, we can see that it diminishes as the surface area worked is greater for the 8RX than the 8R. It's 3.7 litres per hectare for an 8R tire configuration with an 8-meter cultivator, while with an 8RX with a 12-meter cultivator, we have consumption of 3.2 litres per hectare, which is 13.5% lower consumption. That's 0.5 litres less per hectare. So here we have a quick assessment of this increase in productivity. If you stubble plow 1,000 hectares, you save around 5.5 days of work. Of course, the greater the surface area worked, the better the investment. Thank you, Guillaume, for this explanation about productivity. So at John Deere, would you like to add any comments to this table? Sébastien, perhaps? Yes, just to reiterate that the 8RX is truly a new tractor in terms of traction capacity, as we can see here. So, when customers choose to make this investment, it would also be important to have a general overview, as we can see in this table. What width of tools to fit to optimize tractor performance, that's a crucial element, as we can see here. But in fact, there are two factors. Either we try to work faster with a machine with higher traction capacity, or we prioritize the width of the rear tool. It's true that with equipment like this, as we've seen, the 8RX is a little over 20 tons. The energy which is sometimes required to travel faster in terms of working speed, that requires a lot of energy, power, so it's perhaps better to prioritize the width of the tool, as we can see here. And we can also draw a parallel with machines with very, very high capacity, like harvesting machines, notably the very large combine harvesters. And it's the same principle with the cutting widths. This opens up new opportunities to optimize equipment with these high-capacity tractors. Thank you, Sébastien. That's the end of the traction and per hectare consumption section. So I suggest we move on to another point which is very important, which is agronomy and soil preservation. So before going into detail on the test, the same question, Damien, on this point. Do you have some feedback to offer us or findings in terms of the soil you work with? Could you give us some details of the soil types you work with on your farm and if you noticed any differences between your configurations? Yes, we have two types of soil, as I explained in the introduction. Light soils, which we work superficially. No deep tillage, so a tractor fitted with tires, for example, with the Rapid 8 meters, the Van der Stad seed drill, we get excellent traction while preserving the soil, because we're looking more for speed without working deeply. So we achieve excellent tractor handling, and in terms of soil preservation, it's very interesting. On the other hand, as you will see, this tractor with tires at lower speeds, with deep work in clays, where we need to transfer the power to the tires, and we realize that during slippage there's also horizontal compacting, which digs in slightly, and we can even see wheel tracks behind the cultivator. So in terms of soil preservation and compaction, in my opinion, the work is not as good, and just after, if we take the same tractor, we already did it in the same plot, even with the Terraland where we changed tractor in the same plot. Straight away, better traction and no soil compaction when working with a heavy tool and pulling a heavy tool. So that's what we found. Okay, and just a little extra question. For the sowing activity, you said you used your Van der Stad, the Rapid 800. Are you generally happy with your 900 tire configuration? That is really an important question, because from an impression which is a little, not negative, but a little disappointing about the tractor for traction, we use practically all of the tractor's power when sowing, because we work quickly, as we mentioned just now. And when speeding up using the tractor's power, we're very satisfied with the 900/65 R46 tires, which hug the soil well. They don't seem to compact an area. We only have two tires, they're not twinned, we're at 8 meters, and when the crops emerge, we can't see the tire tracks. So we're very satisfied with the tires for lighter work, like light stubble ploughing. The tractor is suitable. Okay, and regarding ballasting, we know that sometimes some farmers leave their weights on, perhaps for comfort or a lack of time for work like that. How is your Hectare configured in terms of weight when you're sowing? For us, the goal is to tailor the ballast to the work and for it to be quite quick to change. And so the Hectare, when sowing, it doesn't have ballast on the front or rear and no wheel weights either. Okay, so we could say it is at its minimum weight, and yet we reach maximum power. We can see it on the tractor's power indicator. We reach 100 to 110% using the additional power, and the slippage is low, 6 or 7% maximum. So we're satisfied with the tractor fitted with tires. We don't currently plan to use the tractor for sowing, perhaps later with direct sowing where traction or direct sowing might be higher. Okay, thank you for that detailed feedback, Damien. Laurent, the same question in terms of compaction, soil preservation. Have you noticed any differences with your Hectare and now your Hectare X? Yes, definitely. Particularly for sowing, I saw that there were fewer marks left in the soil. Okay, so remind us, your Hectare X is fitted with 960 R42, which is the lower dimension. Yes, absolutely. And in terms of ballast, the same question. How did you fit it? Did you have no weight like Damien, or were you still ballasted? We ballasted it for heavy work with wheel weights, and for lighter work we used the hoist, and we removed the weights. Okay. And your feedback on sowing, are you happy with the Hectare X in terms of soil preservation? Yes, absolutely. And with the comfort. Okay. I forgot to say, in terms of soil preservation, there was a negative aspect with tracks, particularly the RT. We don't have it at all with the RX. The ends of the plots where the soil is damaged at the end of the plot when we turn. We even have a significant shift in soil, and in terms of soil preservation and the ends of fields, it's a little troublesome, but something which doesn't happen now, or much less, with the RX. Okay, so you really improved performance in terms of the U-turn at the end of fields, which we will discuss a little later in our highly visual fashion. So now we'll move on to a presentation of the soil preservation tests. Several tests were carried out. For these tests, it's important to remember that the load factor remains the most detrimental factor for soils. And it's very important to have the configurations in mind. As we saw, we have tractors with a configuration where we have a weight of 15.5 tons up to over 20 tons. So 5 tons difference. And once again, load is one of the main factors for compaction. So we must keep that in mind. To carry out these tests, we called on experts outside the Michelin group, who we work with very regularly. Specifically, we worked with the Haute École Spécialisée Bernoise, who I'm sure you know have a tool, software called Terranimo, which allows you to estimate compaction depending on configuration and soil type. And to try to consolidate results, but with protocols different from those used by Haute École Spécialisée Bernoise, we called upon Agrotransfert, which is very well known in France, notably for its research on soil compaction and with different protocols. The idea was effectively to consolidate results and to have robust results on this performance. So we will start with the footprints in the soil, with what happens on the surface, and then we will go into the soils to effectively see if there's a link with the footprint surface area and what happens in the soils. So I will let Christophe present the results and footprint measurements. Yes, so we will start by presenting the results of footprints on sand. So even if these measurements do not necessarily give an indication of what happens in the soil, we know that an equivalent load, the larger the footprint, the less the soil will be impacted. To help explain the concept, we sink into snow less when wearing snowshoes as they reduce the load and pressure per square centimeter. The figures that you see ringed in yellow are the cumulative total size front and back of the footprints in square meters. The first configuration in the top left is the tractor with tires, single fitment with VF 960 R42 Axiobib 2, heavy ballast, we have a total footprint of 2.08 square meters for 0.72 kilograms per square centimeter on the rear axle. On this point, we can clearly see the advantage of tall and wide rear tires compared to smaller and narrower front tires, which means that we have a higher load per square centimeter at the front than at the rear. You can see that on the screen. Below, we have the rear twin fitment configuration with VF710-75R42, which increases the footprint by 40% to reach almost 3 square meters. By comparing the rear axles of these two configurations, we can clearly see the advantage offered by the 710 twin fitment, which is just 0.46 kilos per square centimeter compared to the 0.72 kilos per square centimeter for the 900s just above. For the front axle, the tires don't change and remain as a single fitment. However, if we twin the front tires in addition to the rear tires, we get a total surface area of around 3.7 square meters, thus getting close to the track configurations, which are over 4 square meters. And above all, we clearly reduce the load per square centimeter at the front to around 0.55 kilos per square centimeter. The tractor with 4 tracks provides an additional 20% footprint compared to the tractor with a twin fitment at the front and rear. But note that it is also heavier, which means that the difference in load per square centimeter between the two rear configurations is almost nil, 0.46 kilos per square centimeter for one and 0.43 kilos per square centimeter for the other. To sum up, the 710 twin fitment increases the footprint by 40%, compared to the wide single 900s. Adding a front twin fitment to the rear twin fitment increases the footprint by 27%. The 8RX and 8RT offer an extra 20% footprint compared to the 8R rear and front twin fitment. And compared to the 8RT, the 8RX offers an extra 2% footprint despite the narrower tracks at the front. Okay, thanks Christophe for these details, and we can indeed see the benefit gained from the twin fitment. And to answer the question which is regularly asked, should we have a twin fitment or wide tires? We have the results here which answer this question. A good twin fitment, again, as you can see. We have 4 tires which are the same dimension and the same technology, and we can see the 710-75R42 twin fitment offers a very significant improvement, unsurprisingly. As the 900 is interesting compared to narrower tires, we will see a little later that it is beneficial as a single fitment, and it has the advantage that it's more versatile, particularly on the road, I think. So now what we will do is we will look at what happens in the soil. So Christophe, I suggest that you comment on the compaction tests in the video. So, in the video, to explain a little what we did, first and foremost, we started by digging pits that we used to position our equipment. From the pit, we inserted probes into the soil from the side at different depths. The probes are rubber pipes which reproduce soil porosity, or you can even imagine an earthworm in the soil. Above the probes, we didn't work the soil, we left it as is. In the soil, the probes are compressed by the tractors passing overhead, just like the porosity or earthworms would be compacted. And this is the level of compression that we will measure. We took measurements from several plots at several locations in the plots and at different depths of 10, 20 and 40 centimeters. Each time we repeated the measurements several times for each configuration, tires and tracks, including with tractive efforts. We looked at changes to pressure experienced by the probes as the tractor's front and rear axles passed overhead, and we recorded the maximum pressure reached. This complex and precise protocol provides us with robust and reliable results, and you can see the tools passing over the pits. And now, the results of these tests. So, the results I will present to you are the results obtained at 20 centimeters depth. 20 centimeters because it's the easiest to interpret and the most relevant in terms of analysis of the results. To the left of the graph, on the vertical axis, we have the level of pressure in the soil and captured by the probes. As you can imagine, the lower the pressure, the less compacted the soil. So the better the soil porosity is preserved, and the less the earthworms will have suffered. Each colored bar corresponds to the passage of the rear of a tractor configuration. We can see that the lowest bar is the 710 twin fitment configuration. On the rear, the twin fitment offers all its potential here, and logically it's the configuration which generates the least stress on the soil, thanks to a good balance between the footprint surface area and the axle load, which is ultimately relatively low. To the left, you can see that despite the heavy weights, the track tractors, notably the heavy weight for the 8RX at 20 tons, the track configurations have a very similar performance, around 0.6 bar. This performance is achieved thanks to the large footprints which we saw in the measurement taken in sand. For the other tyre configurations, the 710 single fitment light ballast, we can effectively see that we start to have more pressure on the soil, and the 710 single fitment version heavy ballast, this time to the right, the red bar, generates the highest stress on the soil. And this is quite logical, as this is the widest configuration with the heaviest ballast. With an equivalent amount of ballast for a 710 and a 900, we can clearly see the advantage of the 900, which is able to play its role thanks to the width. While we saw little effect on traction performance for the 900, we can clearly see it for soil preservation. A 900 light ballast configuration would have been even more effective, probably close to the 8RT, which is why it's important to remove weights from wheels, which are often unnecessary when preparing seed beds and sowing. However, in all the examples, we are below the threshold of 1 bar pressure on the soil, and even below 0.8 bar for the single 710 light ballast option. Thank you, Christophe. Before moving on to the effect of the front axle, we can ultimately say, without having presented the results to you beforehand, Laurent, Damien, we've confirmed what you said, I think in particular for the 900, for which you removed the ballast for sowing. Let's move on to the front axle. Yes, you can see on the screen, we also measured the front axle. We can see that the stress generated on the soil by the front wheels was higher than the rear wheels. And it's the front that will remain even after the rear has passed over. Ultimately, the front compacts more than the rear. If we take the example of the 710-75 R42 Axiobib 2 twin fitment, with the front not twin for our tests, we can see that the passage of the front wheels removes some of the benefit of the rear twin fitment, so it's important to also twin the front axle to improve performance even more in terms of soil compaction. For the tracks, for the RT, there's clearly no difference between the front and rear, as the front and rear passage is included in the same track. For the RX, we noted the same level of front and rear stress, which shows the positive ratio between the surface in contact with the soil and the axle weight for this configuration. What we need to remember about soil compaction for tyres is that we must avoid transporting unnecessary weight. If you twin the front and rears and remove the unnecessary weight, you'll get the best possible performance in terms of soil preservation. Unsurprisingly, increasing tyre width offers an additional benefit. We can see that when swapping from the 710s to the 900s. Finally, we must prioritize solutions allowing us to work at low pressure, for example, by using Michelin Ultraflex technology tyres, which create longer footprints in the soil thanks to a higher level of flexion. Now, what we must remember in terms of soil compaction for tracks, despite the significant weight due to their length and large footprint, they can be very similar to the twin fitment solutions without the size constraints. Indeed, and this confirms what you told us, Laurent, regarding your satisfaction with the RX in terms of this compaction performance. Indeed, the results confirm that they do very well, as you said, Christophe, despite being over 20 tons. Let's move on to infiltration testing. First, I would like to underline that several tests were carried out in relation to soil preservation and compaction. We also carried out penetration tests, which involve measuring soil resistance, but all these tests did was confirm the test results with the bolling probes. So we didn't want to overwhelm you with too many figures. But we thought it was worthwhile to present the infiltration testing part, which is quite a different test, as it allows you to see what happens in the soil. And you can, with the explanations which Julien will give you, you can carry out these tests on your own farms for a very visual measurement and conclusions. Julien, I'll let you explain what the infiltration test protocol involves. Yes, we wanted to have an idea of the impacts of different equipment on soil structure. So the soil structure is something which evolves over a very long period of time. It's not something which changes overnight. But we have a test which allows us to determine the impact of different equipment at a given moment. And the way we do this is by installing these PVC pipes in the path where a tractor has driven over. We bury them to a sufficient depth, saturate them with water, and once the water has disappeared, we fill each pipe to the top, and we measure how long the water takes to disappear, to measure the soil absorption capacity. And if we do this after different tractors have driven over, we will be able to measure the impacts on soil structure, the ability of water to infiltrate the soil after different equipment has driven over. So this will give the following results. Yes, let's move on to the results and see when the water could infiltrate the most. So on the horizontal axis, we measure the infiltration time, and on the vertical axis, we will measure the amount of water that is infiltrated, and so we measure that over time to compare equipment. The dotted line to the left is the control sample, which is soil with no tractor passing over, which will be the benchmark. The soil is natural, the most water passes through, this will be our benchmark. And then we calculate it with the other tractors. So the closer to this almost vertical line, the less it has affected the water's ability to infiltrate, i.e. the less compacted the soil. So we have conclusions which are quite consistent with the previous tests. For the tractors fitted with single tires, we can see that they've affected the capacity of water to pass through the soil slightly more. Unsurprisingly, the twin fitment improves the situation. We haven't necessarily reached the level of track tractors, but we remind you that we had a rear axle which was twinned, and indeed, not having a twinned front axle will probably have further lowered the curve, and we will see, unsurprisingly, the track tractors. So the track system and the RX have the least effect on the capacity of water to pass through the soil, which seems consistent with the various measurements we've seen. Thank you, Julien, for explaining these tests. Now we will go back a little to look at what is happening on the surface. Damien, you just talked about the 8RT, which you said moved quite a lot of soil about. We're going to show a test which was carried out, which is a very visual test, and I'll let Guillaume comment on this visual test regarding a U-turn at the end of the field. Indeed, we tried to illustrate something which is commonly reported. We didn't plan this, but Damien talked about it earlier, which is the impact of vehicles doing maneuvers on the surface soil, particularly with a shifting effect. We don't have a precise measurement to present, but rather a visual comparison on the video which is being shown now. The process involves doing a U-turn in areas shown by the cones and identical for different configurations. The surface used is a leftover pasture area, it's quite visual. And we noted the impact of the vehicles passing over. With the first configuration, the 8RT with 2 tracks, you can see that on this pasture, the turning circle of the vehicle ripped up the top layer, and thus left quite a distinct mark on the soil. The second vehicle, the 4-track 8RX, there's no shifting. The mark is still clear, which is also linked to its weight, but there's less ripping up of the top layer than the 8RT. And finally, the last configuration, which is the tyre version, the mark is quite small and superficial, so it is the configuration which has least impact on the soils. So now in the rest of the video, you can see the overhead views of these movements. Very visual, and ultimately this confirms what you said, Damien, about the 8RT. Let's move on to fuel consumption on the road, and before presenting the results, the same as before. I'll ask you the question, Damien Laurent. Is this a performance indicator you track? And second question, how much do you travel on the road? Do you have plots which are very spread out? Laurent, you also have a business. Are you required to travel a lot? And what is your road use and also this consumption on the road between the tire tractors and track tractors? We can start with Laurent, if that's okay. Yes, we travel on the road a fair amount, as there are between 25 and 30 kilometers or more between different plots. So that's why we swapped to track tractors rather than twin fitments, because for travel, we had to remove the twin tires each time, place it on a trailer or transporter, and carry them for another 25 kilometers. So it was a waste of time. And it's true. In terms of consumption with the 8RX, I think that we consume a little more, because as soon as it goes uphill a little, it skyrockets quickly. But I don't really have feedback on road consumption. I don't really track it. Well, we'll be able to see the results to give you this information. And Damien, same question about your road use, and also you had the 3 tractors. What did you note about your consumption? Do you have feedback? Well, it's true that the 8,000 with tracks are perhaps not tractors made for transport or a lot of road use. It's more work in the field. And it's the same for us. Our plots are quite far apart, the track takes up less space, and for consumption for us, it's true that the first problem we had with the 8RT is that it was limited to 25 kilometers an hour, so for the consumption, the travel time was significant. And with the 8RX now, which is approved at 40 kilometers an hour, this has allowed us to reduce our consumption on the road, and of course, the tire offers flexibility, as our 8370R fitted with tires is used for transport in the summer. We don't use the 900s for this. We fit the 710s in the summer for transport. And it's true that consumption falls by reaching a speed on the road with lower RPM, and therefore we can decrease consumption even further. But we don't exactly track our consumption. It's really about the visuals and the consumption displayed in the tractor. Okay, we'll be able to look at that in detail. You said that you had a set of 710 75R42 tires, so the same diameter compared to a 900, and you switched for transport, is that right? Yes, it was also to be able to use the tractor to its fullest during the year, so that it is versatile and we can do as many things as possible. And for us, the objective is to preserve the tires as much as possible. And when we work with the soil sowing, we use the 900s. And in the summer, when there's little sowing or for sowing cover crops, we use the 710s. We change the tractor wheels, so 2 sets of wheels for our 8370R. Great. Damien, we understand that you want to keep the 900s as long as possible with this strategy. Let's move on to the results with Christophe. So the first performance figure, consumption in liters per 100 kilometers. Indeed, so to measure consumption, what we did is we traveled several tens of kilometers on the road without stopping. Even though the 8RT is not intended to be used on the road, we still tested the 3 tractors at their maximum speed, and we measured consumption over 100 kilometers. We can see, from right to left, the 8R fitted with 960 R42, which travels at 50 kilometers an hour, with road consumption at 53 liters for 100k. The 8RT, which travels at 25 kilometers an hour with consumption of 73 liters for 100k, so a 38% increase in road consumption. And finally, the 8RX, which travels at 40 kilometers an hour with consumption of 96 liters for 100 kilometers. Ultimately, we can see the tire solution is the most versatile between road and field usage, thanks to relatively low road consumption. Excellent. And we analyzed a second performance figure, which is the effect of speed on consumption with tire tractors. Is that right, Christophe? Yes, that's right, with tire tractors. It seemed appropriate to see the results with differences in speed on consumption. So we carried out tests with the 8R at 50 and 40 kilometers an hour, And what we saw is that by reducing the speed by 10 kilometers an hour, we recorded 13% lower fuel consumption. With the costing indicated alongside that, that could represent a saving of 6,800 euros over 5 years for a tractor with really intense road use, traveling 25,000 kilometers on the road per year. It's up to each individual to decide whether or not the extra cost caused by a higher speed is acceptable compared to the time saved. Thank you, Christophe. So we finished with road consumption. I hope that was clear for you. Would John Deere like to add any comments about consumption performance on the road? Yes, I think we have a comment to make. In fact, we carried out this road consumption test as we also had a lot of questions from customers on this matter. So to have the figures, it gives us an idea. It's very interesting. Now, on top of that, we mustn't misinterpret these results. The tractor is a tractor which should be used for traction work in fields. So it's true that the 8RX offers this advantage, and it was well said by Damien that it travels at 40 kilometers an hour compared to an 8RT, so that's a plus. I think that we should also consider this tractor now, in terms of this road versatility, more for traveling from farm to farm. But it's clearly not a road tractor. So our recommendation is that track tractors are designed for fields, and the tire tractor obviously remains the preferred tractor for transport or versatility. And here this is explained by the result, as you might be surprised, and say that ultimately the 8RX is very, very high. So we must note that there are two criteria. The machine weight, it's over 20 tons compared to an 8R, so there are an extra 3 to 4 tons, which is the first criterion, and also traveling at 40. So quite quickly. But above all, the fact that tracks in general have a lot more rotating parts when moving, which consume a lot of energy too. And that's why at high speeds there's higher consumption to move the machinery. Thank you, Sébastien, for that explanation. So let's move on to comfort. We completed a lot of tests on this comfort aspect, with tests measuring vibrations, acoustic tests. We also carried out a survey with testers to get some subjective feedback and to compile all this data. But to avoid overwhelming you with figures on this performance aspect, which is also quite subjective, we prefer to hand over to the farmers who've joined us today. And then we will show you a video where the farmers in Clermont-Ferrand were able to test the 3 configurations and give us feedback, particularly on the comfort aspect. Damien, a question on comfort between the different configurations, whether on paths, roads or field. What can you tell us about this performance? Firstly, it's true, using the 8RT for the first time was clear straight away in terms of comfort. We said, it's missing something, there's suspension with a buffer. But it's true that with the tracks, the vibrations are quickly transmitted to the cab. We feel it. It's mainly the differences in elevation you can have at entrances to fields, things like that. When the large track turns, there's significant jolting. So it's true that the 8RT is not comfortable on the road, but in the field at a low speed, 8 to 10 kilometers an hour, it's acceptable. And it's a tractor which can travel over all the irregularities in the field without having major jolting. So that's that for the 8RT. Then with the 8R, with its 900s, it isn't used on the road a lot normally with these tires, just transport between plots. It's incredibly uncomfortable, with tire flexibility and comfort, which is very interesting. No vibrations, a very, very nice tractor on the road. So that's that for the two configurations. And we can finish with the 8RX's comfort. It's new for us, it's still young, just 160 hours use. It was one of the reasons we changed it due to the comfort in the 8RT. And we've taken a significant step forward. Just a small clarification, an 8RX doesn't have a suspended front axle. So when people see that, they say, okay, so how can it be a comfortable tractor if there's no shock absorption on the front axle? And we were surprised. It's true, the tractor is very comfortable. In my opinion, thanks to its cab, its seat, and it's a comfortable tractor for transport between plots, travel between plots. A small drawback with the 8RX, we have the same track vibration when it's traveling at high speeds, so that's that for the 8RX. Thank you, Damien, for this very comprehensive feedback. And the same question for you, Laurent, in terms of comfort. What feedback can you offer about your tractor? Very satisfied. In the fields, we carried out demos for Établissement Guénon in marshland with turning. There was no shaking or anything. Even with a small ditch, we passed over it with no shaking felt. Personally, I will not go back to a tire tractor for working in fields. Okay. Thank you for the feedback, Laurent. What I suggest is that I now share a video with farmers who had the opportunity to test the 3 tractors at the end of last year, and I'll let you discover this in the video. It's a great moment, and we can find out about things we wouldn't necessarily see on our farms every day. So for me, I started with the 4-track. I had no particular opinion before starting, so I didn't have a basis to work on. But after I did the one with traditional tires and finished up with the single track. So to be honest, the first impression I had was the comfort. The most comfortable is the 4-track. In terms of traction, I can't say there's a huge difference, as we're not comparing with the same tools on the back. So you shouldn't jump to any conclusions. The most noticeable difference is the comfort. The 4-track is the most comfortable. Then the one with tires, and the 2-track comes last. Am I surprised? Yes and no, because I think that the distribution of the load, etc., is over 4 points, a bit like a tractor with wheels. The footprint on the soil is longer, and I think that it might be that, I don't know, it's just my opinion. As for the cab, the 4-track drives like a normal tractor, while the 2-track drives like a bulldozer. Much more aggressive, a lot more damage in the field when you turn at the end. It's true that the John Deere 8RX feels a lot more comfortable, and as for the traction, a percentage of slippage that is really exceptional. The tractor shows less than 3% slippage, with a big tine cultivator on ground that has not been worked on. The comfort is relatively good on tracks. I think it's really a tractor for working large farms, a tractor that's really meant to be used with tools pulled behind it. This one might be missing a bit of weight at the front to improve the comfort, but as for traction, I think it's pretty good as it has some power under the bonnet. It breathes. As for me, my fields are quite spread out and I have a lot of distance to cover. Remains to be seen if the on-road handling, the speed of wear and the cost that it might involve. Still, these are 3 top-of-the-range tractors. With the interior of the cab, which is extremely well designed and comfortable, the driving experience with the 2 tractors with tracks compared to the tractors with wheels is that they don't have suspension on the front axles, so you can get taken in by the front suspension of the tractor with wheels and think that it's a bit more comfortable. The John Deere 8RX, the one with the 4 tracks, is surprising from the point of view of the traction, and even the comfort can be a bit surprising. The John Deere 8RT is a much more aggressive tractor, very clumsy to maneuver, aggressive and very uncomfortable. Still, all that with a caveat, as these are top-of-the-range tractors. You can see the advantage of the tracks on very dry ground, as we've had in our region for the past 3 to 4 years. In view of the abilities of the tyres nowadays with the Michelin Ultraflex technology and the remote control inflation systems that are now available, there's still nothing quite like tyres for on-road driving. So for the comfort, for me it's tires. After that it's the 4-track, very, very comfortable in the field for clearing stubble and in lanes, but on road I don't know. However, the 2-track, really uncomfortable. But the John Deere 8RX with the 4 tracks, impressive, very, very impressive. What I mean is traction like I've never seen before, much more traction than with tires, very impressive. In view of the price and the level of comfort and wear on road, I would stay with tires, there's no comparison. But if I had a farm property, yes, instead of having a 400 HP, I think I would have a 300 with tracks, so I would save 100 and still have as much traction as with a 400. Convinced by the tires in terms of comfort, no problem there. But honestly, for people who have problems with traction or power transmission, there's no doubt that tracks are miles ahead of tires. It was a very good experience to have been able to compare the 3 tractors. The big track is more basic in terms of comfort and turning circle. I think it's a bit of an oddity. That's a bit more like the first tractors with tracks. Sort of a tank, you could say. The 4-track is really a very good compromise and handles very surprisingly. I think that our structure and soils don't really lend themselves to that setup though. There's no point in having tracks. We make a lot of effort with the tires, twin fitments, we place a lot of store on that, on low pressure tires. But then again, over time we might change, but with our structure, I think that it's better suited to big arable regions with big fields. Perhaps on more sloping terrain than we have. I would say it's not optimal for our farm. Not quite right, but it's still interesting. It's important to be on the ground, to see what's really happening with the test, and to be able to talk to the people who take part in the development of these tires. It's true we're able to contribute through our experience, but we also learn a lot about the technology used to design these tires. It's a worthwhile exchange for both sides. I think it's always a positive thing for everybody. And now we will move on to the final performance figure, which is the performance on slopes. I know that Damien Laurent, you have some slopes on your farms. Damien, could you give us some feedback on tractor performance on slopes? We have some small slopes, we have 2 or 3 plots with significant slopes, and so with the triad tractors, we have never had major problems on our slopes. However, during testing, on the first test with the 8RT tractor on a steep slope, in damp conditions with a top-down 5 meter, the tractor stopped and we said, "There's a problem, isn't there a differential lock?" And no, the tractor with 2 tracks has no differential lock, and it's true that if there's an area where it is not the easiest, the track can start to slip, and the tractor stops. So the performance on slopes is a bit like track performance in damp conditions. We didn't talk about that. In damp conditions and on slopes, the tractor with 2 tracks, it's not great. And so we saw straight away with the 8RX tractor an excellent improvement with the differential lock and the front axle, which helped resolve this problem on the slopes. Thank you very much, Damien. Same question, Laurent, on the slopes. I know you have a fair amount in your region. Yes, particularly on the second farm, we have slopes up to 37% gradient. Even the 4-wheel combine harvester can't get up them. We have to work downhill. We try to go up and down and not go across too much. With the GPS now, it's easy to try and improve maneuvers. And yes, we see a major difference. There's not the damage like with the tire. On the other hand, we have quite a few stones. We try to crush them, but the tracks are affected a little due to the stones. Okay, so what I suggest now is that we move on to the results. So you will see, like for the U-turns, it's something which is highly visual. The measurements are quite unusual to take, but the visual result is very meaningful. Julien, I'll let you comment on the test protocol and test configurations. Yes, of course. So there are some impressive slopes in Puy de Dôme, which allowed us to test the three models in more difficult configurations. So the 8R was equipped with the widest tires and well ballasted, and so the 8RT and 8RX, like the other times, and with a cultivator behind. Two things. So the first pass, we place the tractors facing the slope. It's a slope between 20 and 25%. The ground is damp, so it's not ideal. But this actually allows us to see to maximize the difficult conditions. And in the same plot, they will travel across the 20-25% slope. And the stopping point will be noted when the auto track can no longer continue. The auto track makes sure that we are parallel, and when the auto track can no longer continue, it can no longer keep it straight. And so we'll see the results in the video. Let's move on to the video. I'll let you comment on it.
Je te laisse commenter.
So, a reminder of the configurations. And so there we are. We're facing the slope, so between 20 and 25%, depending on the spot. And we will see the tractors start at the same time, and we will see which stops first. It will turn black and white to signify this. So we already see that there are plenty of difficulties, slippage with the twin tracks, and the tire tractor which is starting to struggle a bit. The twin track has now reached its limit, followed a little bit later by the 900 tire tractor, and the 8RX will reach the end of the slope. So that shouldn't be a surprise. Laurent has bigger slopes which he manages to scale. He just told us that, so yes, the 8RX manages to get to the end. The traction with the 4 points of support helps maximize the passage to keep a certain balance to transfer the power to the soil, which we can see here. The final result, the image is quite telling. We can't necessarily see that it climbed up as well as it should, but it makes the difference. So we already have customers who, with tire configurations, manage to do this type of thing, but we're on damp ground, which makes things more difficult. The tractors have auto track, and we're seeing the 8R has left the line. The 8RT too, and we will not see the 8RX leaving the line, as it kept the same line until the end. Again, the 4 points of support, the track, it's something which has a certain level of traction, and the fact we have 4 maximizes the number of points of support. So effectively, the 8RX, it's equipment which pulls well. It's equipment which will also allow us to travel with much more safety on slopes, and what we've seen with less slippage too, which goes completely hand in hand with soil preservation. Excellent. Many thanks, Julien, for these explanations. And so you might have guessed that was the 6th and final performance figure. So we're reaching the end of this event. Perhaps to conclude, I'll pass over to the farmers Damien and Laurent. So with the explanation of these test results, which should be put in perspective with your experience, what can you take away? Some feedback to share with us, Damien? It's very interesting, and I would like to thank you for carrying out these tests, because we ask a lot of questions, we note things, and some things are definite, and as we can see here, there are some surprising results. If used properly, twin fitment could perhaps be a very efficient tool when talking about the cost of the tractor. Versatility, it's not a tool we should ignore, and we should always have it in mind. So thank you for these results. And then, to conclude, it's true that the tractor which surprised us this year was the 8RX, which arrived at the farm, and now we hope that it will continue to satisfy and that it will offer the expected results. Given its high cost, we need to see that it proves its worth over time. Excellent, thank you, Damien. And Laurent, same thing in relation to the results which you've discovered live, and also with the people online. Finally, are there any surprises for you? Yes, it confirms the choice we made for slopes, its versatility, the number of hours. We're almost at 420 hours. That's practically what we did in 1 year with the 8R with tires. And we will use it more and more. And we purchased a combine harvester, and we swapped that to tracks too, to preserve the soil. And thank you for your invitation too. Of course, thank you for traveling to be with us today. And now to conclude, perhaps John Deere, if we want to contact you, how can we do that if we have questions about this equipment? The 8R, the 8RX, etc. What's the best way to get in contact with John Deere? The best way to get in contact with John Deere is our extensive dealer network. Indeed, it has the data. For those who have questions, it helps them to get a clearer idea. And we have quite a few machines. We've started to create a considerable fleet now. And beyond those results, which are mostly attractive, this allows you to go and see these machines in the field. We had the opportunity to have Damien and Laurent here, and we thank them for traveling so far and for sharing their experience. We have plenty of machines in the fields, and the dealers will be able to direct customers to owners who are local, so the easiest thing will be to do that. Excellent, thank you. So to contact us at Michelin, there are two solutions. The first is the Facebook page, which you use to take part in the event, and your Michelin agriculture experts. So you can contact us via Messenger. Our entire sales team is behind this page, so they can respond quickly. And the second thing is to visit our website, michelinpro.fr, the Contact Us section, and you will be put in contact directly with the local technical manager. If you have questions about the tracks, you have the CAMSO site, which offers the option. But as you will have realized today, the Michelin Group offers all the solutions, so you can talk to us. We will be able to easily direct your queries to the track expert in France. So to sum up, I would like to acknowledge the excellent work done by the Michelin technical teams, who dedicated a whole month to carry out these tests, to offer you this information, and to help you make decisions with configurations, to optimize your vehicles. So thank you to them, the test team, for this excellent work. Thank you to John Deere for giving us these tractors, which is wonderful. Having 3 equivalent tractors like that with different configurations, it was really an unbelievable opportunity for us to carry out these tests. And once again, thank you to the farmers, Damien and Laurent, for traveling here. It was important to share and compare experience in the field with results taken from testing. And ultimately, we realize we're quite close to the real-world situation and lots of things matched up, which is great. So, John Deere, I'll let you have the final word. A big thank you to Michelin, because a lot of the work, we supplied the tractors, but ultimately it was you that embarked on this major endeavor. With the 8RX, we try not only to talk about traction, but also soil preservation. It's really something which is increasingly important, but which is not easy to do, not easy to measure, and I just wanted to acknowledge the work done, so we can measure the benefits of one solution or another, or in any event to compare, without saying that one doesn't work, simply comparing the data. It's something not done very often, so I would like to thank you again for hosting us here and for this focus. It's something we really appreciate, and it's always a pleasure to come here to Clermont-Ferrand. Thank you again, and once again to everyone who took part. And for those who couldn't take part, as we said before, we'll make the whole event available as a replay, so you can watch it, share it, and also share your comments on the tests which interest you. We would love to consider them, so we could repeat this type of campaign again. So thank you again for taking part, and see you again soon, I hope.
Merci.